Suppose we wish to answer the following question. A man of height 1.8 meters walks away from a lamp, which is at a height of 6 meters. If the man's speed is 7 meters per second, find the speed in meters per second at which the tip of the shadow of the man moves. So, let's draw a diagram to see what we're actually up against. To start, we have some lamp, which I'll draw as follows. That lamp has some yellow light on top, and this light shines in all directions. And starting right here, so if this is the ground, starting right here is the man. So the man has some height little h, and the lamp has a height which we'll call big H. So there's going to be a lot of colors in this one, but this guy will be big H. Okay. Now we can draw the following triangle. We have these side lengths, which I'll draw in red. We have this side length. Then we go down to here and across. Okay, so this is our triangle that we care about. I'm going to draw it over here as well. That way we can actually see, unencumbered by the actual drawing of what's going on physically, but I'll keep the drawing on here as well. So now we have this triangle, which has a height h. But if we take this little h, we go over here, and then we go down, we have another triangle, right? So all I'm saying is that this guy is h, and this guy, this distance is little h, right? So let's label these side lengths just because it will be easier. So this corner will be A, this will be B, and this will be C. And moreover, we have we'll call this guy E and this guy F. Right, so this point here is E, this point here is F. So what we find is we have, because of the construction of this triangle, you may remember from high school geometry that the triangle ABC, this triangle ABC, is similar to the triangle FBE. FBE. These two triangles are in fact similar to each other. So this guy here means similar to. This guy, this big triangle, is similar to this guy here. Okay, we'll talk more about what that means in a minute, but before we continue, we also know how fast the man is walking away from the lamp. So here, we'll say that for the man to get from here to this blue line, which is, you go vertically downwards from the height h, you go until you hit this, the hypotenuse of this triangle, and then you go down. So that's the distance that this guy is traveling. And this distance here is x which is equal to v, his velocity, times time. So he makes it to this position after a time t. Okay. Then we will say that his shadow goes from this distance here all the way down to here. And this distance, which I'll call xs, is equal to v prime times time. Notice that these guys have the same times. The reason for that is because this man initially is walking here, right? So let's actually draw what's going on frame by frame. So in frame 1, we have this lamp, and it's shining, and we have the man standing right below the lamp, right? So what does his shadow look like? His shadow looks like that. It's shining right, well, if you were right below the lamp, his shadow would be that blue thing right there, right? So the shadow is right below him. Then, in frame 2, maybe he's walked a little distance away now, right? So if we copy this guy, and we move it over to here, maybe he's walked a little distance now, right? So maybe he's out to here. So his shadow isn't going to be right below him. It's going to look like this, right? And that's because the way you find out what his shadow is going to look like is you draw this triangle, and the shadow goes from his feet to where that triangle tip ends. Okay, and as he walks out, his shadow is going to get longer. So here, his shadow initially starts where he is, right below him. But as he goes out to here, his shadow is going to be extended. So the tip of his shadow is actually moving faster than he is. The reason for that is because in the same amount of time, t, they go different distances, right? The shadow is always going to be ahead of him. So that means that his shadow is moving faster than he is. So these velocities are different. And in fact, v prime is greater than v. Okay. So this is something that we know just because of these two distances that we see. Now, this, going over to the geometry side of things instead of the physical picture, we see that the distance C to E, so the side length CE, that's a length, but we define that length as x, so that length is really equal to VT. And, moreover, the side length CB is equal to what? That's the side length of this entire red triangle, so that's XS. So that's equal to V prime times T. Okay, but now we can use the similarity of these triangles. So, staying on the geometry side of things, the similarity of these triangles, so by similarity, we know a fact about the ratios of the side lengths. So we know that for the side length BE, or EB, right? So we know that the ratio EB to CB, that's equal to the ratio of any of the other side lengths, right? So since ABC, this triangle, is similar to this smaller triangle, since they're similar to each other, that means this bottom, if we compare the two bottom lengths of the triangles, right, so CE and EB, these two side lengths, if we compare those two, that ratio will be the same as the ratio of the two hypotenuses. And it's also the ratio of the two heights. So all of these ratios are the same, and that's just some fact about similar triangles. So namely, this ratio is equal to the ratio of, let's say, these long side lengths. So we'll go, that's equal to the ratio of EF divided by the ratio of, divided by the side length CA. So divided by CA. So zooming out a bit, these ratios are in fact the same. So maybe I can color them in, and I can bring this triangle back down. So I'm going to take this triangle, copy, and paste it down here. And I'll color in the side lengths. So here we'll have a yellow side length. So this guy will be orange. And that orange one is AC or CA. So that's what this is. This guy is CA. And on the top of this ratio, we should have this blue side length here, which is EF. Right? So if these triangles are similar, this length ratio should be the same as this length ratio. This guy, so CB, and I'll also have, let's say, this color, and this guy. So this is EB. So the ratio of these two should be equal to the ratio of these two. But we know the blue and the orange heights, right? This is equal to little h. This is equal to little h divided by big H. And that's just because we're given those two numbers, right? We're given the height of the man, which is little h, from here on the left, and that's a height of 1.8. And then big H, which is the height of the lamp, is 6 meters. So we're given that. Okay. Then, can we find the EB and the CB lengths? Well, we're given these two, right? We're given that EC is V times T. So we're given the purple one, right? So rewriting this, we're given that CB is equal to V times time. Yeah, what we're given, sorry, I was mistaken. What we're actually given is this is V prime T, right? Because CB is the distance from here to here. And that is given by V prime. Then, what is EB? EB, here, this distance, is going to be the blue distance here minus the purple, right? This guy minus this guy is this. So that's going to be V prime T minus V of T, right? So just to clarify, this distance here is going to be CB minus EC. And this guy should still be equal to little h over big H. Okay. Then we know what most of these numbers are, right? So firstly, we can cancel a T in each of these, right? There's a common T in the upstairs and there's a T downstairs, so we can cancel all of those. Then what we have is we have V prime minus V over V prime, is equal to little h over big H, right? But this guy is equal to v prime over v minus v prime over v prime minus v over v prime, right? I just factored out a fraction, but that's really equal to 1, right? V prime over v prime is 1 minus v over v prime. And that's equal to little h over big H. The reason that I'm doing all of this is because it asks us, what is the speed of the shadow? The speed of the shadow is v prime. So right now I'm trying to solve for that v prime. Okay, well, I can multiply both sides by, I can add this guy over to the right and subtract this guy over. So all I'm saying is I have 1 minus, so I subtract this guy over, 1 minus little h over big H is equal to, and then I add this guy to the right-hand side. That's equal to v over v prime, right? Then I multiply this guy over and divide this whole thing over. So I say v prime, I multiply that guy over, is equal to v over, I take this whole guy and I move him downstairs, over 1 minus little h over big H. Then I can multiply the top and the bottom by big H, right? I'm multiplying by 1 here. This guy is equal to 1. So I can just multiply the top and the bottom by h. And that's equal to v h over, if I multiply this guy by h, the 1 becomes an h. And then I subtract little h over big H times big H. So this h and this h cancel. So this is our v prime, right? And now we can plug in for what we have. We're given that v prime is equal to v. So let's go back to what we have initially. We have that v is 7. Okay. Big H is 6 and little h is 1.8. So v is 7 meters per second times this guy, which is 6 meters, that's big H, divided by 6 meters minus 1.8 meters. And then if you plug that into your calculator, what you get is that this is 10 meters per second. So this velocity, 10 meters per second, is the velocity of the man's shadow. So 10 meters per second is in fact larger than the 7 that he's moving with. So if you're standing underneath a lamp and you start to move away from it, your shadow, the tip of your shadow, is going to stay ahead of you, even though at the start it was right below you, right? That's what we saw here. Initially, when you're right underneath the lamp, your shadow is right underneath you. So you have the same starting position. But then as you walk away, your shadow starts to take the lead. It starts to get ahead of you. And the only way for that to happen is if the tip of the shadow moves more quickly than you do. And if we know how fast we're moving and we know the height of ourselves and the lamp, we can calculate how fast the tip of the shadow is. Here, it's 10 meters per second. And with that, I'll end the video. Thank you.